So today we're just doing a couple of quick questions regarding number theory. So this one here, question 8, these are both from the mixed exercise in the official Edexcel textbook as well for FP2. So question 8, we're asked to show that 50 to the power of 50, so this might not be very clear, but this is 50 to the power of 50 is congruent to 1 mod 7. So that's just for 2 marks. And the first question as well from the mixed exercise is just using the Euclidean algorithm to find the GCD of 60 and 444, again for 2 marks. So let's have a go at doing this. It doesn't matter which order we're doing, but let's have a go at question 8 first. Question 8. So for this one, we have to show that 50 to the power of 50 is congruent to 1 mod 7. So we have to spot like a bit of a trick to doing this, and this is very common with, you know, these kind of questions. Can you spot a little trick? You know, to help simplify it. And often with these ones where you've got, you know, powers, you've got to show it's congruent to a certain number. The key is to spotting a very simple way of expressing it. So here I've got 50 to the power of 50. Now what would I get if I said 50, you know, what is 50 congruent to? Mod 7. So 50, well, mod 7 of 50 is going to be 1, right? 7 times 7 is 49. So 50 to the power of 1, or just 50, is congruent to 1 mod 7. Oops, my mouse is going a bit crazy. Mod 7. Mod 7. So this is a bit messy. Mod 7. So if I put it here just to make it a bit clearer, that's 50 to the 1, right? Now, think about your rules of indices, so going all the way back to when you were doing GCSEs. If you're from England, you know, we've got to think about how we can get to the power of 50 there, right? Well, this is just the same as writing it as 50 to the 1, all raised to the power of 50 like this. Because now we just multiply the powers through, right? And that's going to give me 50 to the 50, which is what we want anyway. But here, in this line, so we call this line 1, we you know, we've already worked out that this is congruent to 1, right? So if you've got 1 and you raise it to the power of 50, all you're going to get is 1 anyway. So this is just going to be also congruent to 1 mod 7. So therefore, 50 to the 50 is congruent to 1 mod 7. And we have shown that. And there we go. That's question 8 done. Nice and easy. And then question 1, we have to use the Euclidean algorithm. So hopefully you're confident with the algorithm, but let's go through it together. So we have to find the GCD of 60 and 444. So how do we do this? Well, the way I always, you know, teach you to go about doing this is put the bigger number, as this is what it's equal to. So we're going to start with the bigger number. So 444. And now you make it equal to the first number. So what do I have to times 60 by to get as close to this as possible? Now we've always got to be underneath it. We can't go above it, right? We can't subtract. We've always got to add something on the remainder, right? So what's the closest thing that'll get me to this? So if I did 60 times 6, you know, for example, I'd be slightly off. So I can times it by 7 to give me 420, right? So what have I got to add on to 420 to get to 444? I've got to add 24 of them. So that's that line done. Now, we know we're not complete because we haven't got a 0 at the end, so we've got to keep going. Now, at this stage, you shift everything along. So the 60 goes here, so that becomes 60 equals. And then your 24 shifts to where the 60 is. So this is 60 is equal to 24. And now we've got to do the same again. So if I did 24 times 3, for example, that gives me 72, so we're too big, we've got to go under. So it's clearly going to be 24 times 2. So that gives me 48. And then I've got to add on the remainder. So 48 plus 12 gives me the 60, so this has to be plus 12 here. But again, we're not finished, this isn't 0. So again, shift everything along 1. So this becomes 24 equals here. Because I just shift my 24 to there. 12 shifts to where the 24 is. And then I've got to think out what I times 12 by to get 24. Well, this goes into it perfectly, right? I'm going to get left with no remainder. So 12 times 2 gives me 24, so I get a plus 0. So we know the Euclidean algorithm is going to terminate here because we have a, you know, the non, sorry, what's the term? The I've got a 0 remainder here, right? So we terminate here, and then this next expression above, that's your GCD. So therefore, the GCD of 60 and 454 is 12. And there we go. The algorithm is done, and that's your 2 marks to that one.